Imagine a ball that freezes in mid-air during a kick. That's what we call an invariant point, a point that doesn't move. Let's discover this in transformations today. An invariant point is a point that maps onto itself during a transformation. It stays exactly where it is. Similarly, an invariant line maps onto itself. Under reflection in the y-axis, every point on the y-axis is invariant. Points not on the line move to new positions. See how the line itself doesn't move? Under rotation about the origin, only the center of rotation is invariant. All other points trace circles. The origin is our special fixed point here. Example 1. Find invariant points under reflection in y equals x. We set the transformation equal to the original point, then solve the equation simultaneously. We get x equals y. This means every point on the line y equals x is invariant. The entire line is our invariant line, shown here in green. Example 2. Find invariant points under enlargement, scale factor 2, center origin. We set 2 times the point equal to the original point and solve. From 2x equals x, we get x equals 0. From 2y equals y, we get y equals 0. Only the origin, 0, 0, is invariant under this enlargement. Common mistake. Students confuse invariant points with the direction of transformation. Remember, invariant means the actual point position doesn't change at all, not just its direction. Memory aid. Invariant. It never varies. The point always remains in the same position after any transformation. Set transformed point equals original point, then solve. Subscribe to Ovasaabi for more Form 4 maths lessons. Visit ovasaabi.com to practice more questions on invariant points and transformations. Keep learning.